Hello everyone. Welcome to the fourth episode in a series about testing websites and web apps in real browsers using Nightwatch. In our previous episode, we learned a lot about doing in-depth testing of websites and web apps by simulating complex use cases and scenarios. Here's a quick recap. Test hooks using before each and after each, keyboard shortcuts and clipboard using sendkeys function, OS and browser info using capabilities object that contains platform name, and browser version, executing client.js using execute script function, Actions API using perform function, iframes using frame function, when and how to use async await, multi-tab interactions using getAll handles and switch to, emulating geolocation by using setGeolocation function. If you missed the previous episode, I'll add a link to it in the description. Today, we'll first explore different design patterns in writing tests and learn their advantages. Then, we'll dive deep into page object model pattern and I'll teach you how to write tests using this pattern. Okay, let's jump in. Every automation tester has their own way of writing automation scripts. However, when you collaborate in a team or you work with a huge organization, you are bound to use a structural automation framework that implements a design pattern. This helps in code quality, maintainability, reusability, scalability, extensibility, and readability. Design patterns are broadly grouped into three categories. Structural pattern explain how to assemble objects and classes into larger structures while keeping these structures flexible and efficient. Creational patterns provides various object creation mechanisms which increases flexibility and reuse of existing code. Behavioral patterns are concerned with algorithms and the assignment of responsibilities between objects. Let's look at some of the structural design patterns. Page object model is the most popular one of them all and is commonly used in building test automation frameworks to automate UI simple test cases. This pattern abstracts any page information away from the actual test. Composite pattern composes objects into T-structures to represent part-whole hierarchies. This lets the client treat individual objects and compositions of objects uniformly. The facade pattern provides a unified interface to set of interfaces in a subsystem. The facade defines a higher level of interface that makes the subsystem easier to use. Decorator pattern attaches additional responsibilities to an object dynamically. Decorators provide a flexible alternative to subclassing for extending functionality. Let's come to creational design patterns. Factory method pattern defines an interface for creating an object but allows subclasses to decide which classes to instantiate. Factory method lets a class differ instantiation to subclasses. Builder pattern allows developer to construct complex objects step by step. This pattern produces different types and representations of an object using the same construction code. Singleton pattern ensures a class has only one instance and provides a global point of access. Now coming to behavioral design patterns, strategy pattern defines a family of algorithms, encapsulates each one and makes them interchangeable. It lets the algorithm vary independently from the clients that use it. Now that we've gone through some of the popular design patterns in writing tests, let's dive deeper into the most popular one of them all, the page object model. The purpose of a page object is to allow a software client to do anything and see anything that a human can, by abstracting away the underlying HTML actions needed to access and manipulate the page. Here are the advantages of using POM. Code reusability. All screens are independent. Using POM, one can reuse the test code for one screen and in other test cases. There is no need to rewrite code, saving time and effort. Easy maintenance. POM is useful when there is a change in UI element or action by identifying the page or screen to be modified. As every screen will have different files, this identification is necessary to make changes in the right files. Encapsulation and abstraction. Page objects encapsulate web elements or other class members and provide access to wrapper methods that hide all the logic. Let's go back to our code and rewrite our existing test from the previous episode with the page object model design. Let's take this test from the previous episodes, where we go to the home, find the get started button, click on it, and then we find the filter by title placeholder input box. We wait for it to be visible, find the h1 and check if it's install Nightwatch, check the title, check the URL, and then check if the input box has an autocomplete to be equal to off. Now let's create a file to have the page object for the home page and the guides page. Let's create a new folder in the root folder called pages, inside which we'll have a home.js and guide.js. Then we go to the Nightwatch config file and set the page object's path to be pages, the folder we just created. Let's start with the home.js. Here we'll export an object which is going to be your home object, where we'll set the URL to be slash, which is the home URL, and then we can define the elements inside it. We need the get started button. So let's create a get started button object, inside which we'll set the selector to be an XPath, finds an element with the text get started. If it's a CSS selector, we can leave it here, but since it's XPath, we can set the locate strategy to be XPath. Now let's go to the home.spec.js and let's rewrite this line. Instead of browser.element.findByText, we can say browser.page.home.element.find, and inside which we can find all the objects by using at the get started button dot click. We can remove this line and this will work exactly just like the previous line. Apart from this, we can also write commands for every single page. Here we do that using the commands object, which will take functions. Let's have a get started function which clicks on the button get started. We find the element get started button which we've defined here under elements, and then we click it. It's always better to return it so that we can chain wherever we use this function. Now in the home.spec page, we can say home, and instead of this we can say get started and call it as a function. Now let's move on to creating a page object for the guide page. We start with the full object, we export it, and then we create a URL slash guide, and then here instead of directly setting elements, we can also define sections inside the page, which helps us create a nice hierarchy of the page. Inside the sections, we'll have a sidebar which will contain our input box, and then we'll first define what the selector of the sidebar is. So every element inside it is only searched inside the selector, and then we say what elements we want, and then we'll find this text filter, and we say the selector to be an input box with the placeholder filter by title. Now let's go to the home.spec.js and we'll clean this up by using browser.page.guide. We'll store it in a variable called guide page, and then we can right now we can just find all the elements and assertions inside the guide page, and instead of finding it by the placeholder text, we already have defined the element as the text filter inside the sidebar. So we access the sidebar by using guide page dot section dot sidebar, and then dot elements dot find at text filter, and then wait until it's simple. We can do the same here. Let's clean it up even more. Here we are trying to wait for the page to be loaded, so we can call this guide page dot wait loading. We haven't defined these functions yet, but we'll write it here. And then the next three lines asserting the title, URL, and the h1, doing basic assertions on the page. So we'll call it guide page dot basic assertions. And we go into guide, we define the commands, then we'll first start with wait loading. Where instead of guide page we call this dot section dot sidebar dot element dot find text filter, and then we wait until it's visible. We always return this as a good practice. Then we can move all the assertions into a function called basic assertions. And then we return this. The return this only helps very much when we are chaining, but it's not necessary. As you check on the home.spec, all the logic of the page has moved into the page object. This test file looks very clean. This is the biggest advantage of using POM. We can also use the URL variable we defined in the page object by just simply calling the navigate function. So let's go to before each. Instead of navigating to slash, let's maximize the window, and then we find the page.home, and then we say navigate. This navigates to the page's homepage, which is slash. Now let's run this test. And there it is. It's passed. Nice. Today, we learned about different design patterns in writing tests. We also learned more about the page object model pattern and how to write tests using this pattern. I'll leave a link in the description for you to learn more about implementing the page object model using Nightwatch. Don't forget to like our video. And if you want to learn more about testing, subscribe to our channel and click on the bell to stay updated.